Okay, these are 3D printed rotors. This guy in North Carolina made these for me. They're made for 1/2 inch thick, 1 inch wide disc magnets. You notice inside there's kind of grooves here. And that's like when you glue them in, they'll stick in there better. It's not smooth inside the holes. And the middle shaft is for a skateboard bearing, and then have an axle for that, which would be 5/16. And I have ones that go straight through, and you just pop the magnets in there, 1/2 inch thick. And let's see, I got 1, 2, 3, 5 of those. And then I have these, where one side is like this, and then there's that, you just put the 1/2 inch in there, and then you put the smooth surfaces together. So it's like having a plate in between, and the magnets will pinch themselves together. See? And now you'll have like 1-inch long magnets, 1-inch wide, you know, because you have 2 1/2-inch magnets pinching themselves. So anyways, I got 1, 2, 3, 4, 5. I got 3 pairs of those. Then I have one of these left over. I had these done myself out here in Seattle at this place where they do 3D printing for you. And I actually popped these. I drilled all the way through with these and put in 1/2-inch magnets in these. And I had made a motor that runs, it'll have to be north, south, north, south. And it's the same principle as I've been talking about. The coil, when you energize it and pulse it, will be right in between both magnets, right there. So you have 4 coils, one here, one here, one here, and one here. And you get the push and pull simultaneous. You can just do 2 magnets, like one here and one here, and then leave it blank and do north, north if you want. Might even be better that way because of less overlapping fields. But anyways, so I made a stator for this one. This is plywood, and I roughened it up inside so when you put the coils in there, they're going to stick nice. And this one is made for this one. Let's see if you can see that. Anyways, it all lines up. You know, I don't think I can photograph it, but mainly this 4 magnets line up with these four coils. When I make these, I put 2 boards together, and then I drill for the threaded rods that you can hold the stator plates apart with, and you can adjust them, and then one there, and then I drilled it all out with them together so they're exactly the same, So there's what I got for 3D printed rotors. I also was doing optic triggering, and I had the guy make all these things to do optic triggering, where you have a little bit of a light. When it goes through the hole, it fires it. And so I got a bunch of optic triggers, timing discs, but I don't know. I don't think I'm ever going to use these. I'd just rather use Hall effects. There was a reason I was doing optic triggering, was because I wanted to make sure the rotor magnets wasn't interfering with the timing magnets. I was getting some speed up experiments where it was speeding up when I was adding magnets, but people were saying, well, maybe that's just the rotor magnets, or the backing magnets behind the stator coils is reacting to the timing. So okay, I'll prove what it is with optic. So I made a couple optic motors, but I showed those in some previous videos. I'm probably going to take those apart. So anyways, there's a bunch of stator plates over there not drilled out yet. Now, the magnets that go in here are like these. And they cost, I just checked on the internet, they're $14 each if you buy them. K&J magnets. And they're N52s, which is really strong. And this is 24 of them. And then I have another 24 behind all this here with this wood and cardboard all stacked up. So I have a total of 34 of those half-inch ones. And those are 1-inch diameter, so they go right into this thing. These, so, and I don't want to sell these, the ones with the, so I'm going to try to use these with a 1/2-inch shaft down the middle and a couple of them on each end, and try to float the rotor in the air with magnetic bearings. And I also have a bunch of these. These are 1-inch, but 1/4 inch, not 1/2-inch. And actually, I don't want to sell these either because I want to make a big motor generator out of these. And I just thought I'd show them. Something stuck to it. So Jim was asking me if I had anything else to sell, so I do have more stuff than this, but I opened up this box and dumped it out. So I would sell these 1/2-inch magnets for $10 each. I have 34 of them. And you can see they're usually $14 or so, 15 bucks each. And but I don't want to sell these magnets because I'm going to use those. And also on my treadmill motor, like the Stargate motor, where if you see chapter 4 of my book, I have these pictures of this go-kart I built, and I stuck like a stack of like 3 or 4 of these stuck together, and then I have a line of about 4 of them. I think I have about 32 magnets like this stuck on the side of this treadmill motor housing, and it makes the motor go way faster, way more powerful. And so I'm probably going to be taking that apart. But anyways, I got all those magnets stuck on that treadmill motor too, like same as these. And but I don't want to sell those right now. But anyways, these are for sale, $340 for all 34. I don't know. And all these rotors have a, I'll try to link it in the description of this video. I did make a motor with these, with north-south, north-south, and it runs on alternating DC, AC. And it's the motor that when you grab the shaft and you slow it down, it goes down and draw, not up and draw. And it's pretty good motor design actually, because you have one magnet pulling and one magnet pushing on the coil, and you have 4 of them, all with 4 coils. So, and it also makes it so it's kind of instead of the magnet kind of pulling it, pushing it away or pulling it to the magnet, it makes more of a sweep sideways power to it. So it's just a better way to make a pulse motor, I think, is having north, south, north, south, and then the coils here, 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 and here, and then alternating the pulses in polarity each time, so it's like AC. So, oh, what happened here? So this is one of my original stators, and what the problem is when I made them with these, I wanted to make wider coils, a little bit wider coils than the magnets are. But then you have problems because you don't have any room for the shaft coming through. So this one kind of no good. So I made it so you have to have smaller diameter coils, and that's what goes on here. Will go between, you know, stator to the left and stator to the right, and this in the middle with the magnets. So that's what that video I'm going to link is about. So anyways, all these 3D rotors, 1, 2, 3, 4, 5. I don't know, I'd sell them for I don't know, $100 maybe, something like that. So anyway, so here's some more things if Jim wants to buy them, or maybe someone else does, but I can just keep them and start making these motors like this too. Like I was saying, it might be better to make these with just one here and one here, a magnet at 180. Maybe not though. I have to try both ways.